So now for question number 17, we know we need to keep our head on the swivel a little bit. We need to pay attention for the possibility of extraneous solutions. Typically speaking, it'll prompt you in the directions to think about extraneous solutions. So even if it wouldn't have occurred to you that these problems have such a thing, it's nice to note that that's now something that we should be focusing on. Now, this question, fortunately, is going to work much like number 16 did. The first thing that I'll do is pick up on the product property, the plus sign, so that I can condense the problem down into one single log instead of two separate logs. If I condense, I'll still have log base 2, and then I'll multiply the x from one of the logs times the x plus 6 from the other log. Remember, you do technically have to multiply that x times both parts, so x times x is x squared, x times 6 is 6x. So a bit of distributive property, if you will, but I'll condense this problem down now into one single log. By condensing it into one single log, now I can rewrite it exponentially. Because once I have a single log, it's a lot easier to see that exponential form take shape. And if we write it in exponential form, we'll start with a base of 2 to the power of 4, which is equal to x squared plus 6x. Just like we saw in number 16, this has all the trappings of a potential trinomial. I have an x squared and an x. I just need that third number. So 2 to the 4th is going to be 16. This is definitely looking like a trinomial now. I just need to move the 16 to the right-hand side to join the other terms. So that means I have x squared plus 6x minus 16. Remember, that's equal to 0 now because I moved everything out of the left-hand side, but that's good, because now I can just factor it and set my factors equal to 0. Again, you can use whatever factoring method you like. Diamond problem, guess and check, anything you suit, or anything that suits you. But your factors should be x plus 8 and x minus 2. So you'll set each of those factors equal to 0. X plus 8 equals 0, and x minus 2 equals 0. If you solve the first factor, x plus 8 equals 0, you'll definitely end up with negative 8 as an answer. X minus 2 equals 0, you'll end up with positive 2 as an answer. You'll notice I purposely didn't write those in the answer spot though, because technically they're not correct answers until we check to see if either of them is extraneous. My instinct, based on what we saw in number 16, is that negative 8 is not going to work. If I plug negative 8 into the first part of the original problem, it's going to fail. Log base 2 of negative 8 is not going to work. And if you happen to be blessed with a calculator that can do that, or even Desmos where you can type it in, you'll actually find, not surprisingly, whoops, math, log base 2 of negative 8 is indeed non-real. Log base 2 of negative 8 won't work. So negative 8 is immediately out. We know that's not a legitimate answer. That must mean 2 is our legitimate solution. Now we shouldn't take for granted, we should check 2 just to be sure. So again, if you have access to such a device, this would be a helpful, thing to try. Go to math, log base 2 of, and I'll plug in 2, plus math, log base 2 of 2 plus 6. And sure enough, we get 4. The original problem had a 4, so we know we're good to go. The general rule of thumb is negative answers don't work, positive answers do. So even if you don't have a calculator, you're not necessarily stuck. Just remind yourself, negative answers don't work with logs, positive answers do work with logs. And that's a good rule of thumb going forward. You can never have a log of a negative number. If you went back now in your head and you're like, whoa, hold on a minute, Herbert, loophole. Like, I got negative answers to some of the problems up at the top of the page. Like, number 4, we got a negative answer. It's not actually wrong. It wasn't extraneous. Do you notice why? Because when you plug negative 4 back into the original question, you're going to square it. Negative 4 squared becomes 16. And log base 2 of 16, totally doable. Doesn't break any rules. So there are some loopholes for sure that we have to make sure we address with these, and that's why it's so important to just kind of now pay attention to the idea that logs only have positive inputs. That's basically the moral of the story. Logs only have positive inputs. And if you want to make that as a note to yourself, it is worth noting, because that's going forward going to be something important to note about logs. In math analysis, when you study the graphs of logs, that'll actually even more enhance the idea that logs only have positive inputs, because you'll see why on a graph it works. But for now, just make sure that you're using that as a rule of thumb when you're doing questions 17 through 22. You'll probably get 2 answers because the majority of these questions will work out exactly like you see here, where you're going to factor. You're going to get 2 factors with 2 solutions, but one of them will be negative, one of them will be positive, and you'll use the positive answer as your real solution. Your negative answer will be extraneous and you'll ignore it completely. Try the best you can to do numbers 17 through 22, but again, don't fret. As I've said in other playlists, this is just meant to give you an idea of what's ahead with logs, but if this is just over your head at this point, don't panic. You'll see a lot of this again in math analysis, and you'll have plenty more time to build up this foundation. For now, just try your best. The more you can do, the better, but don't panic too much if it seems as though it's too abstract or too different. This is a lot to learn, it's a lot to take in, and logs are brand new, so give yourself some grace. Do the best you can, use the answer keys, use the resources you have, but ultimately just try to get comfortable with the idea of log, even if you don't end up finishing every single problem.